Hi class, I wanted to do another example of graphing when A is not 1. We need to do lots of factoring. We're going to practice, practice, practice because factoring, if we don't get this by a second semester, you're really going to struggle. So I wanted to do another example, just one problem per video. That way you can get some extra practice. So I chose number 17 in your packet under the factoring. This was for set 3. So set 3 was kind of the harder ones, okay? So in number 17 says 6y squared minus 5y minus 21. So the first question you want to ask yourself is there a greatest common factor? Is there a number that can go into A, B, and C? And in this case, there's not, because 6, -5, and -21, there are not one thing that goes into all three of those. So there's no greatest common factor. So if there isn't one, you can skip to the next step. And so the next step is A times C. And so we call this the AC method. So let's write down our A, B, and C. So A in this case is 6. That's always the number in front of the squared variable. B in this case is -5. That's always the one in front of just the variable with a 1 exponent. And C is always your constant. And so in this example, it's -21. And so we want to do A times C. And so in this case, we have to do 6 times -21. So 6 times -21 gives me a -126. Now there's going to be a lot of factors for -126. And you could start listing them. But what you need to do is you need to make sure that you're close to where when you add the factors together, you get B. So remember, we're going to find different factors. But when I add the two factors together, I should get -5. Okay? And so we can start thinking about different factors. So we can do -126, and you can do like divided by 3, but that's really big. You get 42 times 3. That's not going to get us close to a -5. So 3 is not big enough. So you want to go a little bigger. So let's try like 9, right? So if I have 9, 14 times 9 is 126. And we need one of them to be negative. Well, it's a -5, so you're going to want the bigger one to be negative. So the question is -14 plus 9. Is that -5? And in this case, it is. So these are what you're going to work with right now, right here. Okay? The next step is to look at A. So A is not 1. If A was 1, we'd be done, right? We have that shortcut we learned last week, but A is not 1 in this case, so it's a little harder. So A in this case is 6. And so sometimes you can just use A and divide both of these by A and then simplify, right? And so let's try that out. So if we divide both of these by 6, and then we simplify where we can. And so over here, 9 over 6. Well, 3 goes into both of those. So 3 goes into 9 3 times, and 3 goes into 6 twice. So this reduced to 3 over 2. Okay, and then we want to reduce the 14 and the 6. Okay, well, 14 and 6, the only thing they have in common is 2. So this will reduce to -7 over 3. Now, the denominator is what you put in front of the variable. So in this case, we use the variable y. So this is going to go, and it's going to be 3y, and it should be -7. Okay? And then this guy, this denominator, is going to be in front of this variable, and then we have +3. Now, there are other ways to do this, so you need to make sure that you have done it correctly. So to check it, you re-multiply this out. So we're going to do 3y times 2y, That gives me 6y squared. We're going to do 3y times 3. That gives me 9y. We have a negative 7 times a 2y. That gives me a negative 14y. And then we have a negative 7 times a 3. That gives me negative 21. If I combine like terms, you'll see that middle part is a negative 5. And so we did this correctly because we end up with 6y squared minus 5y minus 21. And so since we got our original back, we know that these factors are correct. And so it's a little bit extra steps. So just be careful when A is not 1, you need to divide both of your factors by A and reduce where you can, okay? We'll try one more problem, and then I want to do some notes for some other ones, okay?